like 2/5. It's 2.5 out of 5. I mean, it's not really 50% of the time because Fridays aren't really the same and everything. But yeah, that's why we're not really following CPM this year. What's up, Miss Allie? Oh, just hanging out. Trying to remember some math. So we have quiz 5 in there. Please try to get to that before Friday. So going back up to the top of this, so we have field days this week. I think, maybe, depending on rain and Ohio and who knows. But I've heard that I will still get to have math with you guys. So I'm pretty sure on field day that afternoon, there's just one block for math. So I think you guys will still come to me. Today, we're talking about interpreting quadratic models and rewriting in other forms, and we may play some Desmos. I've got tons of games in Desmos that we can play if we run out of things to do. So these problems are exactly like what you're going to see in Khan Academy. Cough, cough, hint, hint, nudge, nudge. They might actually be the same. Cough, cough, hint, hint, nudge, nudge. So if Suraj has a hovercraft, and we're trying to model it using that quadratic, here's where people are having issues. It asks us to rewrite the function in a different form, factored or vertex, where the answer appears as a number in the equation. So what we have to think about is which form of the quadratic would represent the answer. Well, what is the answer that we're trying to answer? The highest point. So for highest point, we're going to need to write this into vertex form. So what I want us to put in our notes is go ahead and write down this trinomial. And we're going to write down that we need to put it into vertex form. Not factored form, but into vertex form. Today is the 20th. For everyone dating your notes like I have asked you to. Top right works very well. So today is actually 10/20/20. Fun little date. And what did I say we're actually like working on today? Interpreting quadratic models. That's it. So if we're heading our paper, interpreting quadratic. Now, guys, this problem is not easy. So when I like pop around the room asking for help, you can pass, or just be comfortable taking a risk, right? What happens if you get the answer wrong? I turned off the fire cannons, so nothing will happen if you get the question wrong. No worries. Yeah, I have the little the things from Mario that pop up and open their mouth and just shoot a fireball out at you. I have a few of those. I turned them off, though, so don't worry. If we want to try to get this into vertex form, we remember that vertex form is the type that has... So, actually, I'm going to make a little... We want this to go into vertex form. And vertex form is that whole, like, f of x equals x plus or minus something. Right, we said h, right? Squared plus, we called it k. Right, yeah, but we called them h and k, right, back when we wrote down this notation. So if we're trying to stick with what we've written on our notes before, I get all shadowy over here. Sorry, I realized maybe my lamp needs... Ooh, that's warm. So, crap. I don't want a coefficient inside of here. And when I look at this, what could I do with this? Yeah. Yeah, factor out not just 4, negative 4. So if we factor out a negative 4, t squared, this now becomes minus... And guys, I want to show you a method we haven't done in class yet, but it's another complete the square method that totally works. Oh, my bad. Sorry, I was already in my head thinking about the next thing that we're going to do. So this is where my head got broken. I'm actually... What mistake? I don't know what mistake you're talking about. So, guys, I want to show you something. There's another way that we can do complete the square that might be easier in your brain. Instead of, like, subtracting this over to the other side, we, for a moment, just, like, ignore it. We just say, okay, go away. It's kind of like when, like, your little brother's following along, like, you know he's behind you, but you're like, whatever. So, if I actually separate this and say, I'm going to group this binomial and say, little brother, you get out of here, then I'm going to factor sorry guys, this is why I wrote that down wrong. This is what was in my head. Like, this is what I have prepared for class. I just messed up. So why, does anyone have a prediction why I might be setting it up like this? So we can make it a perfect square. Now we still could have, even if we had the 32 in there, or even if we pushed the 32 to the other side of the quadrant. Like, has anyone watched through a, like, how do I do this, where they did this method? I like showing you options, so that's why I'm showing you this option. If we then keep going, and we think about turning this into a perfect square, so we'd have t minus, we do half of b, right? So t minus 1 squared. But remember, when we first started talking about complete the square, we know this isn't true yet. Because if this is true, I don't want to forget about my plus 32, so I'm going to go ahead and bring it down. Although I'm not quite sure exactly what I'm going to do with it. If this was true, and guys, even if you've already done this homework assignment, I'm probably teaching you a method that you haven't done yet. What would the constant be? 1, right? Positive 1. There's a reason I'm showing it to you this way. So this makes, this trinomial is this, right? But to get this, we had to add how much to our problem? 1 times negative 4. We brought in, on the right side, we brought in a negative 4, right? So for this up here to have the plus 1 necessary for it to be true, that's actually a negative 4. So since we essentially subtracted 4, or brought in a negative 4, to compensate for that, we're going to add 4. So up here, we're going to add 4. This is the same thing as if I had moved the 32 to the other side and then had to mess with both sides. Or, guys, or the other method is if we subtract 4 from the left side, we'd also have to if we subtract 4 from the right side, we also have to subtract 4 from the left side. The reason I'm not doing this, we don't want any numbers over here. We want this to be 0. So I don't want to take the way where I do things on both sides like we normally did, like we, as a class, normally did the method where we pushed the 32 over to the other side. But now, since we know we don't want that, and I talked in a previous day about saying, yeah, we don't actually have to do that step. When we look at, okay, I added a 1 in here, which actually was a negative 4 to the right side. I need to add 4 to compensate for that, which really means that this 32 has an additional 4 with it. And this, which is true now, has a plus 36 instead of a plus 32 now? Who's confused and can actually formulate a question? Because I know this is confusing. I just wanted to teach you this other method that you might see, especially because I survived college by Googling the math that I didn't understand when we did it in class. Guys, they say that for every hour of class you have in class in college, you can expect 3 to 4 hours of out-of-class work. And that's why they, like, your credit hours is always, like, a lot more than the hours that you spend in class. That's literally how college works. You go to class and you assume I will spend double to quadruple this amount of time out of class working. And for me, a lot of times it was reading math forums.
James Tolbert, please come to the remote office. Thank you.
All right, so one more time before we move on. To make the perfect square happen, we had to add 1 to our trinomial, which actually subtracted 4 from the entire right side. So then we added 4, so that what we actually did was add a net 0. We didn't add anything. We added a couple things, but the net, when we put them together, the net was 0. And the reason we did all that was so now we can write it as h of t is negative 4 t minus 1 squared plus 36. And that is our vertex form. Now, so let's talk about what that negative 4 does for the situation then. If we plugged this into a graphing utility, which you know I'm going to pull up Desmos. Do we remember what we said? Remember we call that our leading coefficient? Do we remember what we said that does? He's right. So guys, if I just plotted x minus 1 squared plus 36, the vertex is at 136. But if I plot that same thing with my leading coefficient of negative 4, my vertex is still at the same place. My vertex does not change. So that's why this is vertex form, is what we were searching for, was the vertex. So at a t of 1, right, we can go back to like what we have written down. Our vertex, we now know, is 136, which tells you at a time of 1, h of t, the output, the y, quote unquote the y, is 36, which I think is like feet. I think they told us is feet up. How many minutes after takeoff did the hovercraft? Oh, just 1 minute, so it was 1 minute. Meters. Woo! Meters. That's a lot of meters. Would you guys ride on a hovercraft that was 36 meters in the air? I don't know that I would. Guys, if it flips over, you're 36. You're like 100 feet up in the air. Over 100 feet. Maybe. They do have jetpacks now. Have you seen those, like, human jetpacks? They've got, like, thrusters on your hands, so you control your up-down. So you've got, like, the backpack thruster, but then there's feet thrusters and hand thrusters. So there's a video, he's, like, on a patio or a porch or something, and he just, like, walks forward and, like, hops, and he's flying. He's freaking flying, guys. People can fly. I don't know if you're excited like I am, but people can fly. Amar. You what? Oh, yeah, your clothes lighting on fire. I thought I had another problem about this one. Maybe not. All right, now hold up. How can we figure out when the hovercraft will reach the ground? Yeah, it's 0, right? So if they asked us to model when it would reach the ground, well, that would want to do in factored form, right? So this is the trick of what they're asking us of factored or vertex form, is if we wanted when it reaches the ground, that would be factored form, not vertex form. So if we move on to another one, guys, keep these notes, by the way. These are going to be very useful when you do your Khan Academy. So a flying squirrel, speaking of people flying, a flying squirrel jumped from a tree branch, floated to the ground. The squirrel's height is modeled below. Suppose we want to know the height of the squirrel above the ground at its highest point. This is where you do it on your own because we just did it together. Now, you can use whatever method to complete the square you want. You don't have to use the strategy we just tried, but I'm going to, just to continue practicing those strategies we're not as comfortable with. I wasn't just being teacher excited. When I saw that video of a person flying with like a flight suit, I kind of cheesed out a little bit. I don't care if no one says it anymore. Did you say it's not the 1900s? You're right, that was 20 years ago. I am from the 1900s, though. I am from the past. Who wants to be put on the spot and tell me what we can do? Avi, what can we do? Factor the -2. Because of your help, I will now forgive those videos in Khan. No, my brain just remembered. I saw your email. Don't worry about that. Like, if it's not giving you the credit, I'm more worried about you guys doing the practices. You have to get to 750 victory points is what it actually, or energy points, not victory points. Sorry, that's a game we play. So if I factor out a -2, t squared minus 2t. Now, wait a minute. Are you factoring out the 30 also, or are you leaving the 30 off on its own?
I just factored it, and then I did it to the side again.
No, wait. If you factor out of the 30, it's not off to the side. It would be stuck into our trinomial.
I did that there. So, like, right there, I put it at -15, and then off to the side, I did it where it's not.
Oh, so you did both ways. So then if we went this way, man, I mean, this will work. This is good review. I should not shy away from it. I should have left it in between. No, I still can. So half of b is still t minus 1, right? Squared. For that to be true, this would be t squared minus 2t. What does our constant need to be? +1. All right, so to make that true, this is why this gets so complicated when we're working with factored forms. To make that true, we have to turn our -15 into a +1. So we add 16. But is that adding 16 or is it adding 32? Is it adding 32 or adding -32? Oh, man. What? Guys, I'm going over here. We can do it this way, but the reason I showed you the other way is this just gets really complicated. It's not like bad, it's just complicated. If over here I leave the 30 out on its own, you know, maybe not out in the snow on its own, but you know, just out here on its own, then this we said needs to be a +1. That actually is a negative 2. So if we think about that, right, it's actually a negative 2. So we then, to compensate for that negative 2, just have to add 2. This will justify, it would have been a negative 32 over here. It would have been a negative 32. So now if we rewrite this, t minus 1 squared. This is true now because we added the negative 2 and added the positive 2. Now what this would have turned into is negative 32 out here, which hopefully you can see how if we did the algebra, we'd get the positive 32 on the right side or the negative 32 on the left side. Kayla?
I got that, but instead of negative 2, I got like minus 16 at the end instead of 32. So probably somewhere in there.
Over doing this method or the right?
I did another method.
Hang on, then I might just want to come look at yours.
Yeah. Maybe.
Did you split the 30? Did you turn that into 15 first?
I did at some point.
That might have been what you didn't want to do. Let me come check your work in a second. So let's just finish this real quick. So if this is my perfect square form, which we had to add 1 up here, which was really negative 2 because of the multiplication. So we added a negative 2, added a positive 2. That's how we got the 32. This then tells us our vertex is, well, opposite of that. So 1, 32. We believe. We believe. All right, let's come look at this, Kaylin. Fast forward. Then you add it, and this was. So you did all that just getting to your zeros. Yeah. That's fine. That may be the same answer that we did. I'm not saying that you necessarily made a mistake. That might be fine. But in trying to get it to factor, or sorry, not factor, but the perfect square form, you can just leave that negative 2 that we factored out. Now, I think what might be happening is like, so if we divide both sides by negative 2, so Kaylin, this might alleviate any concern you have. If this is true, then what is also true is that. Yeah. So you're good. You just went a different route. So if we're asked to find the vertex, you don't really need to get rid of this negative 2. And we don't really need to mess with this out here. It's 132 is what we get for the vertex. Now that tells us after 1 second, the squirrel is whatever, feet, meters, whatever this label was, that far off the ground. Now Kaylin took it a step further and said, all right, when does the squirrel hit the ground? So that's where, even if we have this vertex form, I would actually then, yeah, I would put it into this form so we can then divide it out to isolate the t. Right, so exactly what Kaylin did, get rid of the 32 on this side, so we subtract it from both sides, and we get negative 32 equals negative 2 times t minus 1 squared. We divide both sides by negative 2, and then we get 16 equals t minus 1 squared. Any questions how we got to here? Because then, Kaylin, what'd you do to both sides? Yeah, we're getting zeros now. So t minus 1 plus or minus 4 So t is going to equal a positive 1 when I add that to both sides. So if t equals, well, either 5 or negative 3. So which of those answers makes sense? 5. He's not going back in time. Well, unless he's a magic squirrel. But yeah, our squirrel hits the ground at 5 seconds. That's a pretty long flight time. I mean, if you think about it like in Mississippi's, like 5 seconds is pretty long. It's falling with style right there.
To be fair, if a flying squirrel jumped like off the ground and just like off, like it just like glides from like a tree.
Yeah. So there's a Reddit page called Well That Sucks. And as it's, I just scroll Reddit to waste time. Somebody lost their propeller on their plane while they were flying. Which then it just turns into a math problem. And actually the people that like were commenting on the video, it's funny because the propeller comes off and you hear the engine like rev up really high because now the propeller starts, like the spinning thing can spin really fast because there's no propeller. And he just looks around. What do you think he's looking for? Place to land. Yeah, now you just have to land. Now you're falling with style. Now you're Buzz Lightyear, right? If your propeller falls off, you are now Buzz Lightyear. You are falling with style. Is this the same? No, it's slightly different. Oh yeah, Antoine and his ball that he throws off the balcony. Now, so, well, his dog is on the ground. When I first read this really quickly, I was like, Antoine, don't throw your dog off the balcony. So let's figure out. Now, wait. What's this question asking? Before we move on, I guess, I meant to ask this. Before we move on, does the method that we just did with that other way of completing the square, does that make sense? Where we can just bump the constant out and leave it so that we never have to deal with constants on the other side. Does anyone have any remaining questions from this method? Yes.
Wait, so 16 equals t minus 2 1 squared. If you subtract 16, wouldn't that mean there's a different vertex?
Yeah, but that's a different function. Because if you factor back out, or like multiply back out that function, and by different, I mean same. So if we subtract 16 from both sides, right? Gotta love algebra. Then what we have is 0 equals t minus 1 squared minus 16. So this vertex is 1 negative 16. It's a completely different situation. So that's why the form that actually like describes our current situation has to involve the negative 2 leading coefficient. Because like Kaylin said, or like somebody said, this flips the parabola over. So it's actually like concave down, right? Opening downward. So that it can actually model something being launched and falling. So if we take away the negative, that unflips it, right? We no longer have it flipped up like this. And if we take away the 2, what does it change? The steepness, right? So if I take away both of those, what I end up with is a less steep parabola that opens upward. It would look something more like that. And seriously, so that 1 negative 16, that vertex is like down here somewhere because it's a different function. It's not the same function anymore. We algebraically, we could get back to here, but it is modeling a different function because when we divided on both sides, we had a 0 on the one side, right? That's kind of goofy. Because that doesn't, like, it doesn't do anything. Nothing changes. So I divided, but nothing changed. Algebraically the same, but not, it doesn't work out the same. Does that make sense? That's why we're looking at the different forms of if we want to get it to vertex form, we just want to do this with it. We factor that out, but we don't actually divide it. We just factor it. So actually, I really, really appreciate your question. This goes to kind of remind us, don't get rid of important pieces to our function. I can divide both sides and get rid of that, but that completely changes my function. I need this to be the function that we actually want, which is why we end up with 132, not 1 negative 16. Do we want to do one more of those? Hold on. I think I already have this problem copied. Tom and an entertainment company. No. Maximum profit. I did not copy it, but I have another good one. All right, so Tom started a business. Tom's profit is modeled. Sorry, not profit, net value. With V. Well, I was about to say the person who answered this question got it wrong, so. V of t equal, well, that's why I'm covering it, because we got it wrong when we went and tried it. Guys, I'm assigning you homework you don't know how to do. That's the thing. Like, then you come to class, then we talk about it, then you should know how to do it. So that's Tom's profit model. And we want to know, when will the company be at its, sorry, not profit, value. Value, Hudson, value. V of t, right? So value over time, or value of time. Tom wants to know, when should I buy stock? Which, to buy stock, do you want to buy low or buy high? Low. You should be doing math, dear, not drawing. Especially right now, because we're doing problems that we haven't all done. Okay, well, I couldn't see what that word said. I see now. So Tom wants to know where literally where this company's value is going to bottom out, is like a term that we call it. So we want the vertex, but the vertex is going to be the bottom because we see the leading coefficient is 4. So if we factor out that leading coefficient, this is just really good practice to do again. We're going to get 4 times, now wait, I'm going to kick this negative 28 out of the problem, right? So out of the factor, I'm going to just leave him out here. I get t squared minus 6t. And we're probably going to add or subtract something right here, which is also going to cause us to do the opposite out there. We now think about, okay, if this was t minus 3 squared, it would actually have to be what would the constant be if this was our perfect square? 9. So for this to be true, we need a 9 up here, which means what number goes out here? The opposite of 4 times 9. So now, and this is why I'm writing in green again, because this is true again. $50.64. So t in this, yes. My bad. Opposite of what's in here, what you have on the outside, so negative 64. So there is kind of this saying about, like, when you start a company, you lose money for a certain amount of time before you ever start making money. And, like, this is seriously how we model certain things, is using parabolas in situations like this. So if we looked at this graphically, what does this point tell us? It's our 0, but what does that tell us? That what? That is our break-even point. So we will lose money for the first 7, is it months or years? Well, you guys don't have the problem up. Months. Yeah, so for 7 months, we will lose money, right? The value of the business, when I started the business, the value was already negative. Right? It costs money to start a business. Then we lose money because it takes money to start a business. We keep losing money. Finally, we start selling stuff, right? Money starts to come in. And after 7 months, hypothetically, we'll break even and then start being profitable. That's why we would use a model like this. All right, so now, because we did one more practice of those, I feel a little bit more comfortable. This is not a trick question. Read this, and then somebody volunteer for, oh, well, yeah. How high is Antoine's balcony? Katie Ann? 16 meters, right? Our y-intercept tells us where we start. So guys, problems like this, we don't even have to rewrite, right? We just look at it. We just observe what's given to us. What about this? Same function, right? Same function. What's it asking now? It's asking for a 0, and only one of them will probably make sense. So factor this. Find the 0. Is that a of x? H of x. If we just want to factor it, we can pull the negative 2 out first if we want. How many seconds until the ball hits the ground? Kayla? Ooh, I don't think so. Yeah, I'm getting 4. I'm curious how we got 10. So, I'm betting you didn't factor out the 2 to start. And I factored out the negative 2. If I try to go a different route. Negative 2x times x. So if we don't factor out this negative 2, here's what becomes really complicated. The outside is going to use that negative 2. And that's going to mess with my middle binomial, or middle value, my b value really. think that works. Kaylin, is this close to what you had? So the tricky part is this becomes negative 4x, and this becomes positive 8x, which is how we get the b value of 4x. Dude, the only reason I knew how to build this is because literally I distributed the negative 2 into this binomial, and that's how I got my negative 2x plus 8, because I just distributed this in. I will swear to you, though, it's normally easier to get rid of the leading coefficient and factor it out with no coefficient to x squared. Normally, if these things are factorable, normally that's easier. Try to find your mistake. If you can't, let's chat. I have you guys till 32. I got 5 minutes. These are fun models. Yeah, let's answer this question. The price that they charge for the bracelet is the input. The output is the profit they make. I want you guys to try this on your own. Looks factorable. Be careful with the negative. Oh. Is what I did right? Yeah, now what if I get to this point and I'm like, darn it! I meant to do vertex form. Is there anything I can do to save myself? Alina? Keep going, yeah. Ooh. Not negative 6 and negative 2, positive 6 and positive 2. In case we accidentally went factored form and want the vertex, remember, we can find the vertex from the factored form. We look at our roots that we have, and we find the middle of the roots, and that's the x of our vertex, and then we can plug it in. So we would run it back up and say negative 2 is 4 squared. Now this still leaves you with some math to do. So you could also just do perfect square form. I'm going to try to take an aside just to do one more of these. I did. I got the fine point pens, which are much nicer to write with. But then they get rounded off. Yeah, that's the problem. I can only use them for like a week. And I write heavy. Like I push hard on my paper. I think, yeah, if I had left the negative 24 to play on its own, and then I factored out the negative 2, so this would have been negative 2 times x squared minus 8x something. If this is true, then this will be a 16. So if I add 16 in here, that was actually a negative 32. So we add 32. Negative 2. I like how a lot of times, and guys, this will happen more and more as you get further up in math, by the time you can ask the question, your brain has another chance to process, and you catch yourself. And you're like, oh, yeah, oh, the opposite. Yep, uh-huh. So always feel free to ask those questions out loud. It helps your brain process. Remember, this is a judgment-free zone, so we're all here to just learn together. To all my people playing along at home, thank you very much. Hopefully this is beneficial. And to those of you here playing along, I think we'll have a field day on Thursday, and then I will see you guys at some point in the afternoon, because I normally have an off block. Your 8th grade teacher should have talked to you about it. The biggest thing I will say is dress in layers, and you might want to bring an extra pair of shoes, potentially. If it keeps raining through tomorrow, I would definitely bring more shoes, but I think tomorrow's supposed to be okay. Guys, for you guys, Thursday looks beautiful. Like, Thursday is going to be gorgeous. Tomorrow's field day is going to be a bit chilly, so for your friends who come to school tomorrow, tell them to dress in layers.
Isn't it going to be like 70 degrees?
On Thursday, it's going to be like mid-70s and sunny. Yeah, you guys are going to have a really nice field day. To those of you watching this at home, sorry, your field day tomorrow is just not going to be as nice. All right, have a great day, guys. Thank you.